Hello everyone, welcome back to AppDev channel. In today's video, we will get to know more details about the scalability. What is scalability and what are the different types of scalability options available. So scalability, availability, reliability, right? All these elasticity, right? All these features are very important features for an IT system must be following. Then only if a system is scalable, reliable, available, then only the customers will be will be attracted towards your internet-based e-commerce applications, and you will be getting more and more revenue. Then only your organizations will be improved. So that important is all these features are. So as part of this video, we will try to know what is scalable. Okay, scalable means ability to change well with the increase in the workload. Suppose if there is a more work coming to me, I have to stretch myself, and if there is less work coming to me, I don't have to stretch myself, right? So that's what is scalable, how scalable I am. Similarly, when there is an e-commerce application, right, and there will be in the peak seasons there will be so many requests, 1 million requests or 10 million requests in one day or in a 1 week duration, right? So the system should be able to handle or the serve all those requests coming in. Okay, so different scalability options that are available are vertical scaling and the horizontal scaling. We will see in detail about vertical scaling and horizontal scaling in the subsequent slides. So what does it mean by vertical scaling? So vertical scaling means there will be one high performant machine or the CPU will be there. Suppose if so many requests are coming to your application, and you should not be running into out of memory errors or the out of disk errors, right? Then what you will do is you will increase the memory size or the storage size, like the storage. If you don't want to, if you want to store so much of information, right, the employees information, you will increase the disk size of that particular machine itself. So it will if so many more requests are coming in, you will further increase the disk size of the same machine. Suppose if more requests are coming in and you don't want to run into memory out of memory others, then you will increase the RAM of that particular one specific machine itself. So here we are scaling a particular machine of or an individual machine vertically. So all the burden will be there on this machine itself. Okay, but we are scaling the machine vertically here, like increasing the resources of that particular machine, like hard disk or the RAM or any, for that matter, any other resource, right? That is what called as vertical scaling. Okay, coming to horizontal scaling here, right? There will be a machine. Suppose in the peak seasons of your e-commerce application, your machine won't be able to handle, single machine won't be able to handle so many requests, right? Then you will add one more machine to it with the same configuration. So two machines will be serving the requests now. The data, I mean the requests that are shared earlier, served earlier by one machine, that load of transactions will be shared among the two servers now, right? Again, you, if so many requests, more requests are coming in, you will add one more CPU with the same configuration or high configuration. Again, more and more requests are coming in, you can add more and more resource systems, not the resource systems as resources here. Okay, horizontally here. Okay, so by in this case we are scaling the system horizontally, right? So that the requests that are coming to your application will be shared among all these servers. There will not be a burden, or you don't have to load only one single machine itself here. There will not be a burden, and you can share the load on all these machines. We are scaling horizontally here. Okay, so that's what is called as horizontal scaling. So what are the differences between horizontal scaling and vertical scaling? Scale out. Horizontal scaling means scale out. Okay, uh, we are coming out, right? When there are so many requests, we are coming out. That is what is scale out. Okay, when there are so many requests, we are increasing the systems by adding so many machines, right? So we are scaling out. That is what the scaling out means in the case of horizontal scaling. When you are decreasing the systems, you are coming inside. You don't have to, you can deallocate these resource systems, you can deallocate this system, you can deallocate this one when you are having so very less traffic to your e-commerce application, right? Then you are scaling in. Okay, you are coming inside. That is when you are decreasing the systems, then you are coming inside, then it is called as scale in. When you are increasing the systems, you are coming out, then it is called as scale out. Okay, that is what is called as scale out and scale in. But in case of vertical scaling, right, in case of vertical scaling, what we have done, uh, we have increased the burden, or we have increased the resources on a single system vertically, right? So scale up is happening here because we are adding more and more capacity to the existing machine itself, right? That is what scale up, we are going up. And when you don't have so much of traffic, you don't have so much of data, you can deallocate the device or the storage device or the RAM or memory device, right? Then you are coming inside. That is called as scale down. Okay, so in case of vertical scaling, that is called as scale up and scale down. Okay, here in case of horizontal scaling, as we have seen in the earlier slide, we are adding up more and more physical or virtual machines, right? But in the vertical scaling, only one single machine's capacity will be increased by adding the additional storage device or additional memory device, everything. Okay, as we are adding multiple resources in case of horizontal scaling, right? A load balancer is required because as we are adding multiple servers here, right? We have to ensure the load is shared among all the servers. We should not be seeing again this one single server itself is accepting the request. We should ensure the load is shared among all the requests. So we should deploy a component before all these servers that is called as load balancer, and that load balancer should ensure the load is being routed to all these requests, all these servers. Okay, that is called as load balancer. But in case of vertical scaling, as there is only one single machine, then that is not required the load balancer. Only one single machine will be serving it, right? So resilient to failures, the horizontal scaling, because we will have to maintain the data replication strategies, like, right? So one single multiple copies of the data will should be stored in all the available servers. So the request coming to one server for one transaction will also be served if the another server receives another request from the same user. So multiple copies of data will be there in all the servers. So even the one server lost, right, the other server should be able to serve the requests that are coming in. There is no dependency on one of the server failure. But if in case of vertical scaling, if there is only one server available, if that fails, then we are gone. The application will go down, right? So that is called a single point of failure. Data inconsistency in case of horizontal scaling, because we should always ensure the data is consistent across all the servers that are scaled up horizontally or scaled out horizontally, because data, as we are storing the data in multiple servers, right, there may be chances that the data inconsistency happens. So we should ensure the data inconsistency is not there in horizontal scaling. As we are having only one server or one storage device, data consistency will be there in vertical scaling. And here when it is coming to when it is coming to horizontal scaling, right, more network calls are required because load balancer is there, multiple servers are there. If one server has to call another server, then more network calls are required, right? But in case of vertical scaling, there is no network calls, only one server or very less network calls will be there. High cost and low cost, because buying more and more servers will always be high cost, right? That's what it is. So instead of, I mean, the in case of vertical scaling, very less cost when compared to the horizontal scaling, as we have to maintain only one server with the high capacity here in vertical scaling. Okay, that's all about the differences between horizontal scaling and vertical scaling. Thank you for watching. We will meet in the next video. Thank you.